I just wondering why there are nobody in the meeting room, but finally I found that I entered the wrong number for the meeting. Sorry for that. So today I think we will proceed our course by uh, another method for data processing. Is a graphic method. Last week we uh, already learned something about the table. Yeah, how to draw a table properly and scientifically. Not this week we will learn things about the graphic method to do the data processing. Before that, I think many of you are wondering how to do the virtual simulation, and now there is a solution for that. You may just enter this website. Is If you cannot register on our website, just follow in, just type this uh, website to enter in. I will also type this in here. This is our website, and of course, you do not have the account and password, but you may just use this one to from I think TJ. Oh yeah, SCET. Black, yeah, SCET black, and 290, 260, and the same password for the account. Okay, uh, just SCET 260. There is a black here, and this is account, and the same for the password. And the account is from SCET 260 to SCET SCET 270. Okay, so you just try to get one account as you like from 260 to 270. Okay, after you log into this website, you because I'm not from, I can only use the Chinese version of this website right now. I cannot use the transfer function for the website because I'm not using the VPN. I cannot use the Google transfer. But if you are if you are abroad, you can use that to transfer the website into English. And you may here just change your name and your password, anything here. The first line here, your name and your password. Password? Yeah, password here. You may change your password and make sure your name is, especially this is your person, your ID, your study ID. I think it's your student number here. You can change your student number to a correct one. And after that, you may do the virtual simulation. I think the virtual simulation is from, yeah, is here they have the software list if it can be transferred into English the software list, and all these eight different kind of unit operation experiment can be done here, from fluid flow to heat transfer and other uh, unit operation experiment. And of course, if you use a Google Transfer, all of this can be transferred into English. So, any questions if you have, please tell me. And the next week, we will do the first experiment about the fluid flow experiment next week. And for this one, you will do the first one, the for the tube. Okay, the fluid coefficient to the Reynolds number curve measuring. And it has the English and the Chinese version for the operation, how to use the software. And when you enter the software, it has the English version. So it may ask me to, yeah, yeah, this is a fluid flow comprehensive experiment for the virtual simulation. And oh, and this software can only be run in Windows, and the Mac OS cannot be run this software. I'm sorry for that. Language setting, change it into English to continue. Okay. So introduction and play. You may just finish the first one. Determine the smooth tube for the reader's number and fluid resistance coefficient. Okay. So to this week we just be here. Okay. Confirm. Maybe just close it. And to this website, this is account and this is password, and from 260 to 270. Okay, you can choose one to as your own account, and please change your password and complete your profiles, including the student ID, your name, and some other informations. So let's back to the course today. The graphic method to the data processing. Graphic method is a coordinate system is plotted using a discrete experimental data or calculated results so that they can be connected by a smooth curve. By a experiment via experiment, we will get so many different experimental data. So how to get a law or how to get a tendency from these discrete experimental data is what we will do via this graphic method. The advantage of this method is that experimental data are clear and intuitive, convenient for comparison, and easy to get the extreme. So you may easily to find the tendency via graphic method compared with the table method. And differential and integral calculus can be achieved without known mathematical expression in correct figures. So if you choose a proper coordinate, it's easy to find the mathematical expression. Like maybe it's just a line, a straight line. So the mathematical expression is easy to be found. And there are three kinds of coordinate system can be classified via this method. First is a Descartesian coordinate system, semi logarithmic coordinate system, dual logarithmic coordinate system. The first step in graphical method is according to the requirement of tabular method. List all the dependent variables y and the independent variables x. So if you try to use this method, graphical method, you have to draw a table first and list all the parameters in it and find and later according to the table to draw the graphic by itself. So three kinds of coordinates can be used in this method, and I think the first one is the most common. So the last two maybe not that common, but it's quite useful for your experiment. So this is a semi uh, logarithmic coordinate system. The differences is from the y-axis, the gap between different kind of figure is same. Okay, the gap is same, is identical to each other. But for the x or horizontal axis, the gap between figures are different. It's smaller and smaller. So if the uh, value changes and the different axis is quite big, if the value changes big, we can use the logarithmic coordinate system. If the value change uh, in, in some axis is small, we can use the normal coordinate. So from this one, you may see the horizontal system, horizontal axis is log, and the y-axis is just a normal one. Okay, so but if you have this figure, if you have this figure downloaded from the website or provided by our laboratory, of course, you all of you can only have this figure from from the website. Please remember this figure is not enough. Okay, please is not complete. Remember to mark the figure title and the number below the paper. Okay, so below this figure you have to type. You have typed the this one. You have typed it, and this information below it. Figure one. What kind of figure it is? Like maybe relates. Okay, maybe relates number to x. Okay, figure. Yeah. You have to title, you have to enter the name and the number for this figure. Make it complete. Okay. If one variable changes within several orders of magnitude range, use the semi logarithmic coordinate system. So that means if the value range is quite big, so we just use the log system coordinate. What? Logarithmic. Logarithmic. If a little bit of change of the independent variable would induce a great change of a dependent value during the initial period that are an independent variable gradually increase from zero, a semi logarithmic coordinate system should be selected. The maximum changing range in the curve can be extended in order to make the profile clearly. If you need to convert any function into a linear functional relationship, such as the exponential relationship, choose to use a semi logarithmic coordinate system. So, okay, like this one is a dual logarithmic coordinate system paper. both the x-axis and the y-axis, the gap between different value are different, from bigger to smaller, and 1 to 10 from bigger to smaller, and after that from 10 to 10 to 100 is bigger to smaller. So okay, this one is what you may download from the website. And so why we use this kind of coordinate system? Because the function y and the independent variable x both change several orders of magnitude. It is necessary to extend the starting part of the curve. A nonlinear relationship changes into a linear relationship. All these three kinds of reason can be can these three kinds of reason are why we try to use the dual logarithmic coordinate system. So if we use the dual logarithmic system, maybe the mathematical expression can be easily to be found, like this way, this one. If the normal coordinate, it's hard to find the mathematical expression or relationship between x and y. But if we use the dual logarithmic coordinate system, it's easy to be found. Even we can, by imagination, can be found the x and y has this kind of relationship, exponential relationship. And I'm sorry. And similar to this way, and this is a real number to the coefficient, resistance coefficient. It's what we will do for the first experiment, and we will use this dual, ex- dual logarithmic coordinate system, and we can be this expression can be drawn from the figure. Okay. There are some principles for the drawing a curve. First, a figure number and the name must be labeled below a coordinate graph. Okay, so there must have a figure number and the name. If you use the virtual simulation experiment, maybe the name and the number cannot be generated by the system. So you have to add the name and the number to make the figure complete. Because if the figure without a number and the name, we will give you a bad score for that. And second is the data points on different curves can be expressed as different label, okay, symbol, and must be marked, and the prominent prominent places in the figure, legend should be marked. So you can use different kind of symbol to express different kind of parameter, but you have to give us a legend for this different parameter. The third principle is a smooth curve should be smoothly plotted, passing through as many experimental points as possible, or uniformly distribute the points which are not on the curve, both sides of the curve. That means if we use this one as the example, this figure as an example, okay, so if you try to draw a curve by yourself without considering the expression, mathematical expression, so you simply use a line to how to draw a line here. I'm not sure. No, can't. Maybe this one. Oh, can't. Oh, okay. Okay. If you try to draw a line via these different experimental set points, you may draw it into this curve. I think is okay. Okay, make the curve smooth. Make the curve smooth to pass through different sets of data and make the data below and up the curve you're drawn. So simply not draw this way, not draw this way. Okay, not draw this way. Try to make the curve as smooth as possible. Okay, and pay attention to figure proportion and plotting habit. The origin of the coordinate system may be non-zone. So maybe this point is not zero. That's okay. Okay, maybe this point is not zero. But if it is a scientific paper, if it is a scientific paper, this point must be zero. Okay, if it is a thesis or a scientific paper, this point must be zero. But if this is just a experimental report, okay, can be non-zone. In a quantitative plotted coordinate graph, the variable name, symbol, and the unit must be marked on the coordinate axis. For example, if the if we use a Q or the flow rate as the x or y axis, so cubic meter per hour should be marked on the x-axis in the characteristic curve for the centrifugal pump. So if this is the, so that means if we try to use this figure, okay, we have 400, 4,000, 3,000, 2,000, and for the y-axis 200, 20, like that. But that is not enough. This figure does not have the units for both axes. It's wrong. Okay, so we must add the unit to make it complete. Okay, as I said last week, all the figure must be complied with the units, make it complete. Okay, so just make it a habit. That's okay. So like this way, this one is. I think next week you will do this experiment easier. It's the characteristic curve of the centrifugal pump. It has three lines or three curves for the efficiency, the head, and the powder for the shaft powder for the to the Q to the flow rate, and the x-axis is only one, is a millimeter, is a cubic meter per hour, the units, and the y-axis has the we have three different kinds of y-axis. First is head, it's meter, and and the n for the powder is a kilo watt, and this is efficiency. Okay, efficiency, the percent. So that's what you will do for a curve drawing. Uh, if you wrote a paper later and in the future, maybe it's very unusual for you to draw the curve by yourself by hand. I mean, you may use the Excel or how to say that. Orange to draw a figure by computer itself. You just simply entered all the data in a table, similar as what you will do for a handwrite curve. You have to list all the parameters in a table, like here as we said. We, yeah, I think it's here. Not this way. Yeah, no, yeah. The first step, according to a requirement of tabular method, list all the dependent variables and the independent variables into a table. That's what you will do if you use a computer to draw a curve. And after that, the computer or the software, Orange or the Excel, will create a proper graphic by itself. I think some of you might open his microphone to make noise, but I'm not sure who. Let me check. Okay, thank you, thank you. So let's make the graphic method over. So what I try to say is you may draw it by hand according to our course requirement, but in the future you have to draw it by computer with Orange and Excel itself. Make, however, you have to list all the data for in a some table firstly. Okay, so let's move to the next position is regression analysis of experimental data. So for a experiment, you obtain so many different kind of experimental data, and and after that you will draw a conclusion or a curve or a law or a tendency from this different set of data, and how to draw it, the tendency or the law. You may use a figure to draw a curve. However, it's not clear and not maybe not a good scientific, not a mathematical way. So how to draw that? You can use the regression analysis. The two kinds of maybe many kinds of relationship between the independent parameter and dependent parameters. So it's a corresponding relationship and the dependent relationship, fitting the main relationships. Okay, so what is a regression analysis? Is a mathematical statistic method to deal with the relationship between the variables, which can be used to find some statistic north from a lot of discrete points and express a mathematical model as a regression equation, therefore referred to as a regression equation. So regression model. Normally, there are two kinds of regressions: linear regression and nonlinear regression. We may simply use the first one, that's okay. But this one is maybe too simple, and if you in your scientific career, it's not common, but you may learn how to draw a linear regression now, and then later when you do the scientific or research later, I mean, from your PhD or a master degree, you know how to draw it. Okay, so this course is just the primary understanding of how to do the linear regression. And if the regression is a linear regression, and we may it also can be classified into two parts: is a linear readable or unlinear readable. Okay, so for for equation, linear regression, we are required to understand how to do the linear regression, and for the nonlinear regression, we are required to understand what is a linear readable. Okay, what is linear readable? So what that is what you will learn today. Okay, so there are four steps, I think, for the regression analysis. I just read it. Okay, according to the least squares principle, this is a some mathematical method, A set of measured data are used to create a normal equation. Is solved to obtain the mathematical relation expression between variables. That is, says a regression equation. The second step is verify the validation of the regression equation. The regression equation is obtained by a mathematical statistical method. That is an approximate result. So its validity must be quantitatively verified. So we after we get a regression equation, we have to justify if the equation is valid or not. So after that, the third step is according to one or more variable values, predict or control another variable value and determine its accuracy. So this is a predict some point we didn't do the experiment, but we can predict via our expression. Okay. So after that, analyze the factors. If a dependent variable is affected by several independent variables, a primary and a secondary independent variables must be identified, and the relationship between the independent variables is analyzed. So, so the content for the regression analysis can be classified into four steps. First is do the regression to try to create the regression equation, and second is valid. It's to verify its validity, and the third is to predict some set of data. We may not do the experiment, but we can predict the result by our equation. And the last step is to analyze the relationship between which independent uh, variables are most importantly, and the second importantly, and the third importantly. Okay, so that's the steps. The For the unary linear regression is some there are two kinds of tests can be used to do the validation. Okay, first is a correlation coefficient R is used to the significant test, and second test is F test is performed for regression equation, and that is basically what you will learn today is a R test or and F test. Okay, R the correlation coefficient R and also the F test. So we just followed it by one. Okay. The first is the acquisition of a regression line to create this regression to create this equation. How to create? You may just use a curve, a straight line to pass through all the different set of data and to find its A and B. The number n is a experimental points. Okay, so x1, x2, x3, xn, and also the y1, y2, yn. The discrete points are shown in Figure 229 as an example here. A line represents their relationships. Here we just draw a straight line pass through all these points, and here is A and B. And of course, this from this curve, there for each x there will be a y here, y on the line on this line. So this y we call it regressed value, and A and B is a regression coefficient. For each x there will be y here on this line, and of course the y is different from the real y. As it said, the real y is a point is a y-axis to the point for different points, but the regression y here is on the line. The differences between y and the real y and the regression y, there is d, the gap between them. The absolute difference between the experimental value yi and the regression value yi is called the deviation of experimental point from the regression line. Here's the deviation, how to the definition of the deviation. di equal to absolute yi minus yi, here absolute to them, and we can use a expression or equation to draw it, is yi minus a plus bx here, xi here. This is the expression for this curve, okay, for this line. And for each gap, we may use this definition to calculate the deviation. And if we square the deviation to sum it, is q equal to dioxide of each d, okay, each deviation and sum it. The minimum q is a partial derivatives are calculated for a and b, respectively from a absolute equation according to the extreme principle. Okay, expressing principle, it's made them equal to 0 to obtain the a and b value, and this is a least squares principle. Okay, so this is a mathematical method to try to obtain or calculate the a and b. So I think no need to remember these equations. You just know how to, you can use it to find or to calculate the A and the B. It's partial derivative method. Okay, so this is a normal equation for a simple one. Is A plus the X average times B equal to Y average, and the second one, so here we have the definition of the A and the B. The upper and the lower limits of summation are omitted, and the summation is approximately as how to read that? I don't know. The normal equation is solved to obtain the regression coefficients A and B. So here is A B definition. No need to remember it, okay? Because you can find these definitions from any book, some statistic book or some website. And so here are some more definitions. First is sum of squares of x deviations, LXX, and the sum of squares of y deviation, LYY, and also the LXY, sum of the products of the deviations of x and y. So just to make this definition is just want to make the definition of A and B to be simpler, more simple. Okay, simpler. Is A, so B can be equal to LXY divided by LXX. So here is some other definitions, some sums of squares of deviations, LYY, how to draw it, and deviation or residual sum of squares, Q, and the regression sum of squares, U, and the decomposition formula of the sums of squares is LYY equal to Q plus U. So no need to remember that, I repeat, okay? So here is tell you what's the differences between and the relationship between LYY, U, and Q. Okay, so here simply this is LYY. It's the real yi and differences between the average y is LYY. Okay, yi minus y average. This point is a real yi, and this point, because it's from the average y, it's the y average. The differences between them can be classified into two parts. First is the real y, different the differences between the real y to the uh, regression y. Okay, regression y here. Because the regression y is on this line, on the regression equations. Okay, this is q. This is can be written as q. And the regression equation yi to the average y can be classified as u. Okay, so Lyy equal to q plus u. Okay, their relationship between Lyy, u, and q. After that, there is a definition. Okay, the first important definition for today's course is correlation coefficient R. So R, normally we use the bigger R, okay, to represent it is R. Okay, R equal to this definition expression. R is a number, is a numerical index to reflect the linear dependence of two variables. Okay, so R dioxide is equal to 1 minus Q divided by Lyy. So R squares just presents a ratio of regression sums of squares to sum of squares of deviations. This definition or this expression is important, but you no need to remember the expression. You just only know how to use it. That's okay. So I think we have a break. And then for the virtual simulation experiment, uh, you may start anytime you like. No need, and actually no need to remember, no need to start till next week. You can start anytime you like, because the virtual simulation you can do it many times. Okay, in order to get a higher score, but only the experiment itself is not enough. You have to draw a report after you finished your experiment, and the report must include so many components, including the table, the figure, the discussion, and some calculation, example calculation. So after you finish the report, you submit to me, okay, to my email, and I will give you a score according to your experiment itself and the report. So, and my email address is, I think all of you know that, but I will type it in again, okay? So after you finish your report, you submit it to me. And of course, the report, you can modify it anytime you like. But you have to submit the report in 1 week, okay, for each experiment. Okay, we just okay. I think. And for the virtual simulation experiment, if you already have the account, no need to use this recount. Okay, no need to use this recount account if you already have. Let's back to the course. From this figure, we can find if r is similar is close to zero for this curve, for this line, regression line or expression, we can conclude that this point, these sets of experimental points cannot be classified as any kinds of expression. So, but for this one, if r is close to one, plus one or minus one, the y and x relationship can be easily to be drawn as a linear relationship. Okay, the y equal to maybe some x, ax, but normally the r is between one and zero. So we can conclude this line is has the linear relationship or not by calculating the r, how much is r or how much is r squares. If r closer to zero shows the smaller linear dependence between r, x, and y, other nonlinear relationship between them can be present. So from these two figures, the absolute y correlation coefficient is closer to 1, leading to more linear correlation between x and y to these figures. But normally it's between 1 and 0. So how much of it is acceptable? How much of it how much the y, the value is acceptable for a linear relationship? We may find some book or from some website to find the results. So the absolute value of correlation coefficient y is closer to 1, leading to more linear correlation between x and y. How close is to 1 is on Earth shows a linear correlations between x and y. That's what I tried to tell you earlier. The regression line can be used to approximately express a relationship between x and y only when r reaches some level. So what the level it is, indication the significant linear correlation. R minimum relates to the number n of the experimental data points and significant level alpha. The significant level is generally 1% or 5%. The smaller alpha, the higher the significant level. So simply, we just classified the significant level into two parts is 1% or 5%. 1% is better than 5%, and the R minimum is related by the number, the experimental number, and the value of and the level. Okay, the significant level, 1% or 5%. So this is a table, the correlation coefficient. The R value we calculated by our line, we can calculate the A1R. And to find it is bigger than R minimum or smaller than the R minimum. The R minimum is found, okay, from this table, from the table on the left. If the R is bigger than R minimum, the linear relationship is significant at this level and can be described by a regression equation. But if it is smaller than the R minimum, the linear correlation is not significant at this level. Okay, it's 5% or 1%, and n presents the experimental number. Okay, so where to find this table? You may find from your book. I already gave you the part one theory book. Okay, theory book. This one, theory book. And from the pendant. from the appendix. Here is F value table and table of correlation coefficient. So you may find here, okay. But actually, this is selected from some mathematics handbook. So that is to say, from any kind of mathematical handbook, you may find this table. If your experimental number is maybe six, so 6 is your n, okay, n equal to 6. So 6 minus 2, you may find from here. So your n minus 2 is 4. If your experimental data is number is 4, is 6. Okay. So after that, you may check the minimum for 5% significant level is 0.811, and for the 1% is 0.917. After you calculate your own curve expression, you will get a R. And to compare your calculated R to the minimum R here, if your calculated R is bigger than maybe 1% or 0.197, you can draw the conclusion that your expression is linear regression and to 1% significant level. Okay, so if it is smaller, you can get some other conclusion. So we may, like if n equal to 17, okay, this is an example. Okay, so this example, this is the first method to do the validation of the expression equation. First, this is the first method is R test. You may in short, okay, correlation coefficient R number. Okay, normally we use a bigger one, upper one for the R, or R dioxide more easily to see. Okay, the second method to the validation is the F test. Okay, F test is actually use some degree of freedom method to calculate the F value. So the total degree of freedom is LYY, is F total is equal to the number of experimental points minus 1. The degree of freedom of regression sum of the squares is Fu is to M. M is the number of independent variables, and degree of the freedom of a residual sum of squares is Fq equal to n minus 1 minus m. For simple linear regression, okay, so for simple one, the independent variables only has one, like y equal to fx, okay, so only has one independent variables. F total is equal to n minus 1, fu equal to 1, and fq equal to n minus 2. Here are some more definitions about it. Is regression variance, residual variance, and residual standard deviation. And lastly, the most important one is variation ratio F equal to VU divided by VQ here. And it's similar to the coefficient correlation coefficient R. You may calculate a F from your expression figure, expression curve, or expression equation. You calculate the one, and you compare it with the F value from the table, from a from your book, okay, the table from your book, and to find it's bigger or smaller, to get it is a significant at some level. Okay. So the differences between F test and the R test is the level here in the F test can be classified into four: 0.25, 0.10, 0.05, and 0.01. And it's similar to the R test. The smaller significant level, the more the stronger the significant level is. Okay. The more linear regression for the expression equation, generally with a high level. Okay. So after you do after you do the verify the validity, you will predict the accuracy via your established the equation. So after that, you just do some prediction. The prediction is here. You use this S word. Okay, residual standard deviation is S. How to calculate the S? And residual standard deviation of simple linear regression equation S. How to calculate S? And after that, you may predict the Y value from some range. Okay. So maybe the R value, R method and the F method is quite complete to understand. So we just use some example to do it. The water content, example 221, the water content of a product produced by a factory is controlled. It is known that the water content of the raw material affects the water content of the product. So, of course, the raw material content, water content, will affect the water content of the product. So, to guarantee the product quality, the tester in this factory measured the water contents of raw material and the product and obtained a set of data. So from the raw material moisture, the count he measured for 10 different kinds of data. Okay, so the number, the experimental number is 10. And also for different raw material, he get a different product. So the moisture could be different. The first question: what is the expected water content of the product if the warm content of the raw material is 16.5%? Second question is: what is the water content of the raw material if the water content is product is controlled about 70.5%? So for this example, or for this question, we must know the steps, the four steps. First, to establish a linear equation, okay, according to the x and y. Here, y, of course, y is the product moisture. X is a raw material moisture, okay. And to establish a expression equation. Second, to verify the expression validation is at some level significant. You may use the R test or the F test, both are right. And the third step is to predict, okay, to predict. Like this way, if the Y is equal to 17.5%, so to predict how much of the raw material. And then finally, maybe some other controlling method. So just follow the solutions, as it said. Solution, first step, to find the linear regression equation. Here it used some, like the name of it, the name of the method is, I think it's, yeah, the least square principle, okay? To use the least square principle, just some partial derivative method, okay, calculation. You know, no need to remember how to do that, okay? Just use the equation if you can find the equation from website or not, or some other book. So via this method, you may calculate the y and the a and b here. So the regression equation can be written as y equal to 0.196 plus 1.017 times x. So this is a regression equation, but it is acceptable or not. We want to verify its validity. We can use two methods. First, the R method. Okay. Second step, testify the regression equation. R method. So because the number of the experimental test is 10, to check the relationship table, okay, we may check from this book, n equal to, I'm sorry, n equal to 10, n equal to 10, and n minus 2, okay, n equal to 10, so should be this line. And the minimum for the 5% significant test is 0.632, and also for the 1% is 0.765 to 5. So we first to compare with the bigger one, okay, to 765, the relationship is meaningful or not, because the R we calculate value is 0.971. It's much bigger than the 765. So we can see the regression equation is meaningful, or it's significant as 1% level. Okay, we can draw that conclusion. So this is the R test or the F test, similar way. To find the F 0.0118, here one means only has one independent independent parameter is y, and 8 means n minus 2. It's related by the experimental number. To find the value for the F 0.01 is 1126.26 is smaller than F calculated is 132.8. So we can draw the conclusion. The equation is significant as alpha equal to 0.01. So after that, we testified the validation of the equation. So after that, we will do some prediction. The third step, forecast the accuracy of y. So here is y and the y1 and the y2. So I don't know how to read them. After that, we can do the answer. We can find the answer to the questions. If the moisture of the content of the raw material is 16.5%, the y and the y2 is this two value. So the water content of the product is from 16.55% to 17.39%. The probability of this was this big. And this value, 5.4%, is a constant. I think it's here. Okay, it's constant. Okay. The probability of y value falls in some range is constant. Okay. And after that, when the water content of the raw material is controlled at 17.02, the water content of the product is 17.5% on average. Okay, so that's the answer for this question. So for this example, or for the R test or the F test, you just remember how to do that. That's enough. How to do the R test and the F test. Is first to establish a equation. Is first, second to validate its validation from using the F test or R test, and third to predict. And the fourth step is to try to find the importance to compare the importance of different variables. And here, another example. No, I'm sorry. Okay. That's the end for the linear regression equation, and for some for some nonlinear regression, if it is a linearizable, we want to know how to do that. So that's what we will learn after this case. So that's a linearization of nonlinear regression. Many nonlinear correlations in engineering can be converted to linear regression by approximately changing the variables. General method is to approximately convert the independent variable and dependent variable to linear correlation. That is to say, linear equation, which is analyzed by linear regression. Note, in the regression equation test, the formula before linear conversion instead of that after the linear conversion shall be tested. So this is some thing you may not use you may not need to remember. Just follow the step I tell you today. Uh, you just know that. I think that's enough. Like the conversion, so just for some example, like for the convection heat transfer equation of the forced turbulence flow of fluid in a syndrome, how to read that? Okay. Cylindrical. Cylindrical pipe is Lucet number is to B times relative number M expositional and plant N expositional. What is linearized before analyzed? So for this question, we have to do the linearization firstly. We use log, okay, for left and right of the equation. After that, we will get a simpler equation. So y equal to b0 plus b1 times x1 and plus b2 times x2. So here b, m, and n constants are obtained from the regression for this new equation. What? To this, it seems invalid. No, it's valid. No, it's okay. I think it's okay. It's uh, it's valid. Very good. It's invalid. Uh, huh? Oh yeah, I understand. Uh, Yes, I think. So how to use this one in if I want to have more person attendance for this meeting? So maybe to him. Maybe this way will help him. I'm sorry. If it not works, please. If it not if it not work, please. Let's see. Video. Okay. Okay. So after that, is to do the some partial derivative calculations. Okay, similar. Do some partial derivative calculation for the formal equation of the binary linear equation. It's and after that, it will be some normal equation is given according to the above data to calculate the B0, B1, and B2. So here we get the answer. The y ex- expression, the regression equation, can be written as this one. Okay, so Nusselt number equal to 0.024, Reynolds number exponentially 0.79, and Planck's number 0.44. So the expression regression calculation table is for this one, for the upper one, for the lower one. And of course, there will be difference between the regressed value to the real value. So, okay, and after that, it will do some significant test to see its validation, the equation validation. And remember to do the test for the original equation, not for the for this one, for the new one, not for the new one, for the original equation. Okay. So similar, it used the F test to the validation F test to calculate the F total, FU, and FQ, and after that, to get the F value, calculate the F value, and to compare it, the calculate F value to the F value searched by the table, in the table. If it is bigger than the F at some level, we can draw the conclusion that the regression equation is significant and alpha equal to 0.01. So that means this value, this expression is meaningful, is acceptable. Okay. So after that, it will do some prediction, accuracy. Okay, predict some accuracy. That's the thing I want to tell you today is some data processing. Okay, data processing. After that, we will do the experiment for the next. Yeah, for some parameter, for some measurement. Okay, it's related to the instruments I think we used for the pressure meter or the temperature meter and the flow rate meter, flow meter. So for all these meters or instrument, it has some features. So we want to know the features of this instrument and try to know how to get the useful information from these features and how to choose a proper instrument according to our experimental requirements. So first, we will know some basic knowledge of measuring technology, and then we will tell you some important or most convenient, most familiar pressure meter and the flow meter, and also the temperature meter. So first, for the basic knowledge of measuring technology, is the features of the instrument can be classified into two characteristics. First is static characteristics, and then is the dynamic characteristics. There are so many different static characteristics for 1 meter or for one instrument. Accuracy, linearity, and some other. Maybe accuracy is the most important thing. So I think this one you should remember. And other features you just know it existence. That's okay, I think. And for the dynamic characteristics, it's important to some electrical class, but to our discipline, it's not that important. So you just know there is some dynamic characteristics for the instrument. That's okay. So statistic properties illustrate the relationship between the input and output of the measuring instrument and a steady state for the measurement of each value. The study of the static characteristics mainly concerns to the factors of nonlinearity, random variability, random variability, etc. And for the dynamic characteristics, it reflects the response characteristics of the measuring instrument to the input, which changes with time. So the static is without time, okay, stable. But for the dynamic, it changes with time. The features can be changed. First is accuracy. Accuracy is kind of thing we already learned actually last week. The major instrument accuracy is usually expressed as the maximum and allowable relative error is relative to the relative error and absolute error. Okay, so via the accuracy of the instrument, we can calculate the relative error and the absolute error of the instrument. So the measured x to minus the standard x is to delta x is the absolute error of a measured value. So here, accuracy class is a value obtained by determining the minus and plus symbol and the percent symbol from a maximum allowable relative error. The smaller reading on the above instrument represents high accuracy of the instrument, whereas a bigger reading represents a lower accuracy. So normally, the smaller value for the accuracy of the instrument, the better the instrument it is. Is precision accuracy? Yeah, similar, much similar. So you remember precision or accuracy? That's okay. Both are right. I think maybe you may find a clear expression for it in some English book because in precision and accuracy in Chinese they are, I think they are same. I think actually. So uh, for different value of the accuracy, it can be classified into three levels: class one, standard, class two, and the industrial instrument. As it can be seen that uh, the bigger one is industrial instrument, and the class one and class two standard are used for the laboratory or for some. The precision is much bigger. Okay, the precision is much bigger. So if it is a 1.0%, that means the uh, relative error, the absolute error is equal to 1% times the range the, of the measuring. So take this pressure meter as an example. Here, the maximum absolute error is to 1.5% times 4 minus 0 is to 60 kilopascal. Here, 1.5 means the accuracy class. Okay, so it's an industry level, industry class meter. And 0 to 4 means the range of this meter. The range times the accuracy equal to the absolute error of this meter. And here is some example accuracy class determination of an instrument. A temperature gauge has the measuring range between 600 Celsius degree and 1100 Celsius degree. The instrument is calibrated with the maximum absolute error of 4 Celsius degree. Try to give the allowable relative error and the accuracy class of the instrument. Allowable, first, we just use the 4 as a dominator and the range as the denominator. So allowable relative error is 0.58 percent. So the accuracy class of this instrument shall be bigger than this one. So it's 1.0%. It's 1.0 level. Okay, next one is a non-linearity error. For a measuring instrument with a seriatical linear scale characteristics, its accuracy characteristics always deviate from its theoretical linear characteristics for various reasons. Nonlinear error refers to the maximum differences between actual measuring curve and the theoretical line of the calibrated instrument. So, for each kind of measuring, normally the calculate the measured value to the real value, their relationship is linear. However, is a linear relationship. However, the linear relationship may be changed with time or with the usage number and also with the range. Maybe we use the meter and the wrong range or and some extended range. After that the non-linearity error could be obtained or found for the measuring. So, but normally this one is quite small. So normally it's quite small. Okay. And here is a hysteresis error. Hysteresis error is an indicator to reflect the misalignment of the output versus the input curve during the forward running and the reverse running of the measuring instrument. Hysteresis area is usually calculated by the maximum differences between a forward and a reverse running output, expressed as a relative error value. That means if you measured some value to a experiment, you control the input like the flow meter from zero to big to maximum, or from the maximum to zero, the output will be different. Okay, and the differences between the forward and reverse running, it can be classified as the hysteresis error. And also, this area is quite big, is quite small. So, but it has a relation. It relates to our experimental habit. So, for the on-site experiment, we'd better to do the to set the experimental data and do the experiment from small to big, or from the minimum to maximum, or from maximum to minimum, but not do the experiment randomly. Okay, not randomly. Always from small to big, or from big to small, not randomly. Okay, not to change the experimental value randomly. Okay, the next one is sensitivity and the sensitivity limit. I think this value is for the uh, electricity meter mostly. Sensitivity presents the response sensitivity of the instrument to the measured parameter change, refers to the ratio of the output change to input change of the measured instrument and steady state. Okay, the limit refers to the minimum change of the measured parameter required to displace the row of an instrument. Generally, the sensitive limit of an instrument should not exceed half of the maximum absolute error of the instrument. So, the sensitivity means what's the minimum scale, what's the minimum force, not a force, what is the minimum uh, input for your measuring can influence to can lead to the change of the output. So because the output and the input there are some relationship, and what's the meaning? If you want to the output to change, you have to change the input first, right? So what's a minimum change for the minimum for the input can lead to the change of the output. That's the I think the it's the expression for the sensitivity. Okay. And for the digital instrument, resolving powder always represents a sensitivity signs. The resolving powder of the digital instrument refers to the physical quantity expressed by the last digit in the minimum measuring range of the instrument. Resolution is the ratio of the sensitivity to the measuring range and it relates to the significant digit of the instrument. So these features, I think it's useful, but not that important. The most important to the meter is the accuracy and also the range of the meter. But this information you may find from the label or the user's guide for the instrument. If you do some precision measuring, maybe it's useful. But for a normal measuring, it's not that important. And then is the repeativity, repeat repeatability and also the threshold value. Repeatability is an indicator to reflect the constancy of the characteristic curves obtained during the continuous repeat change of the major instrument input as full scale in one direction under the same condition. The closer to one another the characteristic curves are, the better repeatability is. I think the definition of it is quite easy to understand. So just the two lines, if they close to each other, or uh, it means the repeatability is a bit better. Okay. Six is a threshold value is a minimum measured input value to make the output end of the measuring instrument uh, produce a measurable change. Okay. It's related to the uh, sensi- sens- uh, sensitive sensitivity and sensitive limit. Okay, and then is stability. Is stability the ability to maintain? Okay, whatever the sensitivity, stability, and the drift. I think you may just read after this class. Or I just read it to you. That is stupid. I think. Okay. And for the dynamic characteristics is a time constant. The time required when the output value of the major instrument increases to 63.3% of the steady state value. That means if we change the input into some level, how much time suffered for the output also changes to maybe 0.6232 of the desired Y output. So the time consumption here is very small. Is maybe minimum seconds, or not minimum, is a millimeter, milliseconds or even nanoseconds. Okay, nanoseconds maybe. So so that's an end for the basic knowledge of a measuring technology. So for this one, I think you only remember the accuracy. That's okay. Okay, the accuracy class here. Use the accuracy class to times the range, major range equals to the absolute error. Okay. Then we will do something, tell you something about the uh, pressure meter. Pressure meter. Okay. Maybe we have just have a break. I can't find. Can't see it. Oh, I um Obino. So I didn't hear concepts of the first 10 minutes of class. Maybe that's why. Uh, I said maybe it's not easy for you to register for the website. So I simply provide 10 or 11 account accounts to you. Already, already, I'm sorry, already provide 10 to about 10 accounts to you guys to your you may find the information from group. Okay. Okay, let's move on to the pressure measurement technology. First, it can be some classification for the pressure meter. The pressure instrument, according to the conversion principle, or for the here the conversion principle is to some y to x uh, relationship. Okay, y to x relationship principle. It can be classified into liquid column pressure meter, elastic pressure meter, electricity pressure meter, and also the piston type pressure meter. And first is the liquid column pressure gauge. Actually, this is quite important and quite common in laboratory. A liquid column pressure gauge is designed based on the fluid statics, which has a simple structure and high precision. It is either used for measurement of the fluid pressure or measurement of the pressure difference between two tapping points of the fluid pipe. It is generally made of a glass tube, and its normal work liquids, including water, mercury, alcohol, etc. There must be a clear and stable interference between the liquid and the measured medium in order to get a precise reading. The liquid column pressure gauge is used only for measurement of the low pressure vacuum of different pressure due to the lower pressure resistance and the limited length of glass tube. Simply, here is a conversion principle. So, what is convert into? We convert the pressure differences into the height of the liquid. Height of the liquid. Rho GH here means the delta P, the P pressure differences. Here's the height differences of these two height can be converted into the pressure differences. So rho GH, no matter the diameter of the tube is, it only concerned about the height. It can be used, has two kinds of shapes: is U tube differential pressure gauge or reversed U tube differential pressure gauge. In China, we always call this as a pie shape, pie tube, because it's similar to the uh, symbol pi, okay, 3.14 pi shape or the U shape is convert the pressure differences to the height of the liquid. So the liquid can be different, can use different kind of liquid, water, alcohol, mercury, and if the density of the liquid is bigger, okay, so it can represent a bigger pressure differences. If the height, if the density of the liquid is small, the pressure differences it measured can be very small. However, this method, as it said, is only measured of the low pressure, vacuum of different pressure, because the lower pressure differences and the limited length of glass tube. If we want measured pressure differences and a very large scale, you can imagine that the height differences can be very big. The height of the liquid can be very big, so it's not acceptable. So it's only used for vacuum or very low pressure measuring. So this is a liquid column pressure gauge. Second, elastic pressure gauge. So what is it converting to? The pressure differences can be converted by the elastic element. Okay, normally in this way, Borden tube pressure gauge. The pressure change as the pressure changes, this elastic item could be changed. The, the, the shape of it can be changed. So after changes, the needle on the tube, on the table can be indicated at different scale. So during the pressure measurement, the tested pressure medium entered the chamber of the Bonding tube, Borden tube, through a tube joint to achieve a displacement of the free end of the tube. So the displacement, okay, will be changed. After magnification of the displacement of the free end, the corresponding pressure is indicated. So after this end changes the movement of the end, the indicator will indicate into different scale to present the different pressure or different pressure differences. So that is a convert from elastic into pressure. Okay. So elastic pressure gauge joining an internal structure, okay, as you may see. This is quite common for the pressure meter, but this is not precise. It cannot be used for precisely measuring. As you may see here, is 1.6. So the relative error is 1.6%. It's quite big. It's only for industry and for if it is, and of course we in our laboratory also use this meter, but only for some indicator, not for reading. Okay. And next one is the electric pressure gauge. It converts the pressure signal into the electric signal. Okay, so a pressure we use a sensor to find the pressure and use an electric signal to change it into some output instrument. A pressure sensor is detected and converts signals to electric signals for output. The pressure sensor further convert the output signals to standard signals. It's called a pressure transmitter. Okay, pressure transmitter is very useful if not only in industry but also in your laboratory, such as some magnitudes, some filters, operators, etc. The signals from the sensor. They are displaced on the head of the output instrument or output device, such as some graphic meter, printer, screen. Okay, even screen, right? Even from your computer, you can see the pressure differences directly. So use this electric pressure gauge. And then we have another one is a whole chip pressure sensor. This is for some magnetic conversion. You may read the principles later. Okay, this one is also quite important. Even in some computers, it's important. Okay, and then is strain gauge pressure sensor. It's a metal strain gauge type and a semiconductor strain gauge type. You can see the features and the measurement principle. Because it's a hysteresis error and the non-linearity error is a very small. It's useful in some electricity device. It's a work principle. And then in the selection of the installation pressure gauge or meter. According to the display mode, the physical and chemical properties of the measured medium and ambient condition to find a proper instrument. And the measuring range, and then most importantly to find the accuracy class. According to the maximum allowable error calculated from the measure range of the selected instrument and the maximum allowable measuring error during the production. Actually, this data, this feature, you will be find from the uh, 名牌 nameplate of the instrument. So what is nameplate? In Chinese, it is 名牌. Okay. 名牌仪表. So as it is said, you may find this nameplate on each instrument, I think. So all these features can be found there. The accuracy class, the name, the figure, the product time, the factory, many other information can be found here. Even the standard. Okay. Maybe for this one. I think this is okay. It's I don't know what is. But you may find there are so many information can be found in this nameplate. All right. So if you have time, you may notice your own device. Maybe there are some meters you already used in your home, so you can find the nameplate on it and read the information on it to find the feature, available feature on it. Then the most important thing is accuracy, as I said. The installation of the pressure gauge. Okay, so there are some standard in the straightest section of the pipe where the measured medium flows linearly. The measuring point shall be vertical to the flow direction, and the end face of the measuring tube is flush with the inner wall, and the connection between the end face and the projection equipment, free from bubbling. Burr. What is a burr? It is central. To measure the liquid pressure, the pressure measurement points shall be located in the pipe bottom so that no air can accumulate in the pressure tube. To measure the gas pressure, the pressure the pressure measuring point shall be located in the pipe top so that no liquid can be uh, accumulated in the pressure pipe. So for liquid and gas, different kinds of fluid, we may use different kind of location. A mounting angle is different, and the from the top and from the bottom is different for the pressure meter. And tube selection installation shall have approximate diameter and length, of course. And if the medium measured is readily condensable or freezable, the pressure tube must have a heat trace. So in the north of China, because it's very cold in winter, so we have to have some heat trace for the meter. I think, but in south of China, it's not easy to see that the heat trace. A block valve shall be installed between the pressure point and the pressure gauge. So I think that's easy. That's also for the consideration for the condensable or freezable. If the liquid is frozen, is so we have to use some gauge, some valve to close the movement of the liquid, of the fluid. So the horizontal pressure gauge tube shall be installed slightly inclined, so that to make sure the fluid can be moved slightly in the tube. And the pressure gauge installation is some location should be considered for the installation of the pressure meter. Pressure meter is installed in the place where it is easily to be repaired and observed. That is on-site pressure gauge, and also for some electricity pressure meter from the observation room because it's integrated in the computer. So maybe it's not that important. It's not that important to follow the first rule. Second is the pressure gauge is installed in such a manner to avoid vibration, high temperature, etc. So in short, we want the gauge is in a better environment. Is a comfortable environment for the pressure meter. Pressure meter is installed at the same height and the pressure measuring point, or the measuring error will appear. So the height of the meter and the height and the measuring point should be at the same horizontal height. Otherwise, there will be difference between the measured pressure to the and the indicated pressure. So to avoid it, will be better to install or mount the meter at the same horizontal level to the measured points. And also there are some to measure the steam pressure. Coil tube shall be added to avoid the direct contact of the high temperature steam with the measured element. Use some protection to protect the meter. For corrosive media, an isolation tank shall be added. A sealing gasket shall be placed between the pressure gauge and the pressure tube to avoid the leak. Use a vent valve, isolation valve, and the balance valve. All these solutions are used for the protection of the meter because the meter, this kind of meter, are always the elastic pressure meter. Okay, this meter is easy to indicator, easy to read. However, it's also easy to be broken by the fluid. Okay, if it is high temperature, corrosive, or some you has some big particles like solid particles, it's easy to be blocked or easy to be correlated and to be if the temperature is very high, the movement of this end may be easy to recovered, so it's easy to be broken. So then, pressure is quite important in chemical world. The second thing is flow meter. The flow meter can be classified into two parts. First, the volume flow measuring instrument and the mass flow measuring instrument. Generally speaking, the mass flow measuring instrument are the price of it are bigger than the volume flow measuring instrument. The volume flow meter is cheaper, okay, and the volume flow meter can be classified into uh, velocity type and volumetric type. Throttling flow meter, rotometer, turbine flow meter, vortex flow meter, and for the volumeter metric type, it's an oval gear flow meter, pistol type flow meter, and for the mass flow measurement instrument, directed type and the indirect type. That means the meter itself contact the fluid directly or not. Directed type is thermal flow meter, angular momentum flow meter, and Coriolis flow meter. So we just try to tell them one by one. Okay. And theory, the measuring the throttling flow meter. The measurement of the throttling flow meter is by the pressure drop that the flow across the throttling set. Throttling flow meter is usually composed of a differential pressure sensor, such as an offense meter, nozzles, venturi tube center that can convert flow rate in different pressure signal and a differential pressure signal that measures the pressure differences. So in short, actually, the throw meter, throw flow meter is a pressure meter. Okay, it's a pressure meter. We simply convert the flow meter's result into the, convert the pressure meter result into the flow meter. Convert the pressure into flow rate. Okay. Actually, we are measuring the flow meter. Measuring the pressure meter. Pressure. Actually, we are uh, measuring the pressure. Okay. just convert it into velocity or flow rate. Here are some advantage and shortcoming for the different kind of throttle flow meter. Okay, just maybe read it later. But this meter has some, because it is related to the pressure, so it is related to the density of the fluid. For different kind of fluid, the result, the measured result can be different. Okay, can be different. Even it is at the same reading, the result is different because the density is different. Usually, the density is different. Like if we use a pressure meter, if we use a flow meter designed for a water, we use a water flow meter to measure a oil flow rate. It's not acceptable directly, but we can use the water flow meter to measure the oil rate and calculate to get the correct oil flow rate. That is to say, you can use the meter designed for other kind of density, but you have to calculate after you measure it to get the real answer or real value of the flow rate. You have to do some calculations. Okay, here also alpha, this grid value and some other value can be changed. Can be changed. Okay. But most importantly here is the density can be changed with different kind of fluid. So if we want to use 1 meter, we must know what the fluid, what a meter is designed for, what kind of density is it designed for. And if we want to use different kind of fluid, we have to calculate. So here are some selection and installation of throttle flow meter. It's similar to the installation of the pressure meter. You may read it later, I think. And here, as I said, the most important thing is for the calculation. So how to calculation or calibration of the throttle and flow meter is you have to use this equation to calculate the actual flow rate of the readed data. If the density of the measured liquid or gas medium does not equal to the liquid gas standard or designed, the flow rate shall be modified to get the actual value of flow rate under the condition of the measurement. Because the density of the fluid can be changed with different kinds of liquid we use, fluid we used, like oil, water, gas, the density of them are different. Also, the density can be changed with what? With temperature, especially for the gas, right? So if the temperature changes, the density of it could be changes or not. So we have to calculate the actual flow rate by this equation. Here, standard always means the room temperature to 20 Celsius degree. Okay. This is quite important, especially for the gas measuring. Like we have a temperature, we have the pressure meter used designed for the carbon dioxide. We use and to 20 Celsius degree. But the real measuring environment is for like 60 Celsius degree, and the measuring medium is air. So air and carbon dioxide is different, and the temperature is different. So we have to use this equation to calculate the actual flow rate according to the indicated flow rate. Or so we have to do some calculations. That is what I try to say. The second kind of a meter is a rotometer. Rotometer is a theory is a measurement of the rotometer is by the annual area varies with flow rate under constant pressure differences. So here the pressure differences and the different flow rate is same, but but the annual area can be changes. The flow or the fluid moves from bottom to top to make the floating in the tube. Okay, in the tube. When it moves higher and higher, the annual area could be increased. Okay, to increase, and the level indicated to the flow rate is different. Here are also some calculations. As you may see here, the flow rate Q is equal related to the density. So for this meter, we have to notice the density of the fluid firstly before we use. And here is some calibration of the rotometer. As you may see, here's some mostly is for some density calculation or density calibration. This kind of a rotometer and the rotometer is suitable for the measurement of lower flow rate, and the flow rate in pipe with diameter less than 50 millimeter. Because as you may see here, this is a float moves in a tube, so the tube diameter cannot be very big. So the height of the tube cannot be very high. It only can be used in some small flow rate measuring. And of course, because this is read by physical indicator, so the accuracy of this meter is not that big. But it's useful in laboratory because it's very easy to read. Okay, some matters in use of a rotometer. The installation of a rotometer must be vertical. As I said, because it's a flow rate, it's a fluid moves from bottom to top to make the float floating. So it has to install the vertically. Okay, has to. And the float is sensitive to dirt. If there is a dirt, the flow mass, the cross-section area of annual channel will be changed. In that case, the measurement is not accurate. And sometimes the flow cannot be up and down vertically, thus causing the measurement error. The quick opening valve, such as a solenoid valve, is not appropriate to regulate or control flow. Otherwise, a sudden increase of flow rate float may punch to the top and cause the glass tube smash and the glass float crashed. So that means the float can be broken because the tube is always in glass made. So it cannot move very fast in case to otherwise the float will broke the glass tube. cannot moves very rapidly. Okay. The float shall be knocked when moves to the flow meter, especially for large diameter rotometer to avoid the metal float. Makes the glass conical tube broken during the movement. It is more suitable for select the normal measurement in the range of the one-third to two-third scale of the upper limit of the rotometer. Actually, one-third to two-third scale. This this requirement is, I think, is useful to all kinds of measurement because, as I said, as we already learned, the accuracy and the range of the meter, we have to combine them together to select the proper meter. So all kinds of measurement better be in this range, to one third to two third of the arrangement of the range of the measuring, and with a better accuracy class. Then the turbine meter. Turbine meter is somehow if the fluid moves from this direction, the turbine will rotate, and how much, how many circles it runs, and there will be a signal to the there will be a signal passes to the screen or to the indicator to find how many circles the turbine moves, and it changes or combine or convert the rotation number to a flow meter, a flow rate value. So, or simply we can say it to convert the rotation number to the flow rate. Okay, it's the theory for this meter, turbine meter. Okay, and the turbine meter is also very important and very common in industry and also for the laboratory. And turbine meter and also this not venturi, and also the rotational meter, this meter, rotometer, and the turbine meter are most common meter, flow meter in industry, I think. And then we will learn things about thermometer. It's about the temperature. The thermometer can be classified into contact one and non-contact one. So contact one is expansion throat-meter thermometer, pressure type thermometer, and thermocouple and thermal resistance meter. This is contact meter. And for non-contact meter, it's easy to understand the meter and the heat resource no contact with each other. So it's a radiation cyrometer and infrared thermometer. Because I think because the virus today, the non-contact meter thermometer is very common in nowadays. But in industry, the thermocouple meter and the thermal resistor meter are more common. So thermocouple meter, what is thermocouple meter? It is junction to line, okay, to line the to the hot junction to the free junction, cold junction, two thermal electrode to link them together to make a circle. And there will be two kinds of force generated by this proceed. When two different kind of conductor AB contact, due to the different density of the electrons and the electron diffusion rate, electromotive force differences forms between A and B. That is EAB in short. So it's a electromotive force difference. Okay, EAB. And also the temperature differences, electromotive force formed due to the two ends of the conductor and the different temperatures expressed in EAT and T0. So EAB can be ignored in many situations. I'm sorry, ETT can be ignored in many situations because the temperature differences electromotive force is far less than the contact electromotive force. So the total potential is determined by the contact potential. So in short, for the thermal electromotive meter, for the thermocouple meter, we use actually we measuring the thermal electromotive force. So and in the thermal electromotive force, the first one, the contact electromotive force, is more importantly, and we actually measuring this value EAB. And after some calculations, we can calculate the temperature of the item. So ETT here EAB is to this one. Some basic law of the thermocouple meter. We measured, as I said, the thermal electromotive force. And this definition you may read it later if you have time, because for this meter we only want to know or understand. We are trying to measure the thermal electromotive force for the item to get the temperature. Okay. So some of the requirements for the thermocouple meter materials. So the conductive materials should have some features. First is good thermoelectric properties and the physical and chemical stability, and also wide range temperature range, less resistance temperature coefficient, and good mechanical performance. And these features is not easily to find actually. So in many times searching, we have this different combination of the thermocouple meter. Platinum, as you may see here, all these are some very expensive metal. Expensive metal. Mostly is for the first one. Platinum is quite expensive actually. So simply use this expensive metal is not acceptable for the measuring, especially when we just trying to measure some temperature of a like liquid of air or some fluid water. We use a platinum to measure it. It's not acceptable. It's too expensive. So we can use some conductive line to conduct it to extend the line of it. We can only in that case we can use only very tiny. We can use a very small range of material inexpensive metal material to save the material to save the metal consumption. Okay, so we can use other kind of compensation wires of some thermocouple meter. Like we use, if we try to use the platinum, rhodium, platinum, this kind of thermocouple meter, we can use this Cooper and Constantine compensation wires to extend the thermocouple meter to save the expensive metal consumption. And then finally, we can get the principle of the thermocouple meter. That is the electricity, the ETT0 can be classified into this part, and we can use some other compensations thermocouple method to save the metal consumption. And second kind of temperature meter is a resistance temperature meter, or we can use RTD in short. When the temperature is below 500 Celsius degree, the thermocouple meter is tiny and easy to need measurement error. Therefore, RTD is often used for the temperature of the lower temperature in industry. Because for the thermocouple meter, we use the thermocouple meter only when the temperature is very high. Okay, in that case, the thermal electromotive force is big in that case. When the temperature is high, the thermal electromotive force can be big enough to be measured. However, if the temperature is small, this one is not easy to be measured, and so the measurement can be with some error. Some error cannot be omitted. So what can we do if we try to measure a temperature with a smaller range? We can use RTD. Okay. So what is RTD? RTD is actually so in short, RTD is we measured the resistance of this thermometric element. Okay. So here is we are trying to measure the resistance of the material. Okay. In that case, if we find a material has a good sensitivity of the resistance to temperature, so this material is good for temperature measuring. In short, and this part you have to remember. Okay, only this part for the temperature meter. RTD, change of temperature because change of resistance. And for the thermocouple meter, change of temperature because change of the thermal EMF. So what is EMF? Electric motive force. Okay, so the principle for different kinds of meter. So only this part you have to remember for the temperature measuring. And the industry thermal resistance. Okay, so as you may say here, there are some different usage and some different features for this resistance meter. And installation of the temperature meter So similar, okay, similar to the pressure meter installation as well and the flow rate meter installation. Okay, I think all these parts you can read after this class, and of course these things you may find from the user's book. I already sent you. Next week we will do the virtual simulation for the liquid flow. Okay, and you may find the virtual simulation experiment. You may link it to it properly. I repeat to type it. Okay, it's obering.com TJDX 天津大学. Okay, and a, account number. What's SCET? Yeah, SCET. And the black, maybe 27, and I'm sorry, maybe this one, okay. From 260 to 270, okay. If you do not have the account, okay. After that, you choose here the software list, the second one. And the last one is the fluid flow. And you may download some software or environment. And the first one to start. Then do the experiment. If you have time, you may do the experiment firstly. Okay, firstly, before next week, you may do that. And if you do not have time, you may just do the experiment with me. Together, we will do the experiment together. Okay, that's it for today's class. Thank you all. If you have questions, or if you do not have question, okay, we just stop here. And thank you for your time. And next week, the virtual simulation is start from 1 p.m. From 1 p.m. afternoon, Beijing time. Okay, 1 p.m. Okay, so that's end for today's class. Thank you. Thank you so much. See you later. Okay, let me try to stop. Okay. Bye bye.